Good morning all. Today we are going to see about resonator configuration of fiber optics. The outcome of this topic or this section, after completion of this section, the students able to understood the resonator configurations. Most widely used laser resonator or cavities have either plain or spherical mirrors of rectangular or circular shape, separated by some distance L. They have appeared plain parallel resonator, concentric resonator, confocal resonator, gen- generalized spherical resonator, and ring resonator. The plane parallel resonator consists of two plane mirror set of parallel to each other shown below. One round trip of wave in the cavity should be an interval number time to 1. The resonance frequency 1 equal to Kc by 2L. K is the interval number, C is the speed of light. The concentric resonator consists of two spherical mirrors with same radius r separated by a distance L equal to 2r so that the center are constant. The resonance frequency use the same equation above. The confocal resonator consists of two spherical mirrors of same radius of curvature or separated by a distance of L. Next one is ring resonator is particularly important class of laser resonator. The path of optical rays is arranged in a ring configuration or more complicated configuration like folded configuration. We can compute the resonance frequencies by imposing the constraint that total phase shift along the ring path or closed loop path must be equal to the integral number. The cavity can be identified as stable or unstable according to the whether they make oscillation beam coverage into the cavity or spherical out the cavity. The most widely used laser resonator or cavities have either plane or spherical mirrors of rectangular or circular shape of separated by some distance L. The one round trip of wave in the cavity should be an integral number of times to 1. The resonance frequency is 1 equal to Kc by 2L. Kc is the integral number, C is the speed of light in the medium. Light is the cavity of length. The resonator formed by the two spherical mirror of same radius of curvature R and separated by distance L. The ring resonator is particularly important class of laser resonator. The resonance frequency are 1 equal to Kc by Lb, where Kc is the integral number, Lb is the loop path length. The cavities can be identified as stable or unstable according to whether they make the oscillating beam converge into the cavity or spread out the cavity. The breakage is serious because it causes shutdown the production. So far, power ups of 2 kilowatts laser mainly used to stable cavity design laser outputs from the central optical axis. Q switching. If the energy stored in the dominant mode is very large, we get high Q. Q switching means maintaining the population inversion to a very high value above the threshold population inversion and simultaneously bringing down all the atoms to the undergoes laser transition. They will lead to a gained pulse with very high power. The energy pulse E equal to h into lambda nq minus nt into V. Mode of locking. Mode locking. Mode locking is a technique in optics by which laser can be made to produce pulse of light extremely short duration on the order of picoseconds or femtoseconds. The basic technique is induce a fixed phase relation between the modes of laser resonance cavity. The laser is then set to the phase locked or mode locked. Interference between these modes causes the laser light to produce and train pulses. Depending on the property of laser, these pulses may be extremely brief duration, short few femtoseconds method for producing mode locking in a laser may be classified as either active or passive.